Every once in a while we face problems, situations that are different from what we want them to be. And this can be anything, no matter how big or small. A maths problem that you wish to take from unsolved to solved. Maybe there's a person at work bothering you and you wish they stopped. Wanting to eat healthier or wake up earlier. Or maybe you want to learn a new skill or fix your heater. The list goes on. But leaving specifics aside, it's always beneficial to improve our way of approaching problems, from understanding which parts they consist of, up to actually taking the steps towards solving them. Someone once said that all life is just putting out little fires here and there with no end in sight. And I think that a big part of enjoying life is moving past the unreal idea that one day there will be no more fires, but rather learning how to put them out well and how to put yourself in situations where the fires you do have to deal with are the most enjoyable to you. And here's where physics can help, because we as physicists are specialized in solving problems. We spend our lives doing it, in most cases it's our job, and because we commonly face difficult, abstract, long, tiring, and often new problems that no one has ever tackled before, one of the most important parts of the training of a physicist is learning the structure of how to efficiently approach any problem. The first step is generalizing, because why solve each problem one by one when you can try to find solutions that can be applied in many cases? That would make things easier. So, whenever you're tackling something new, try describing only its important and defining characteristics, so that it can be categorized together with previous, similar things, and that might give you an initial idea about how to start solving it. So here goes the most general description of a problem ever, and this will be very abstract at first, so bear with me. Given a system that is currently in a state, and that takes inputs that can change its state, how can I find good enough inputs that are likely to change the system from its current state to a state close to the one I desire it to be in? Don't worry, I'll give an example to illustrate the idea, and then we can go into how you can make this general description sound a lot more like your problem, whatever it might be. Example 1. I'm gonna go to the store to buy some groceries, but I don't know what I need. Of course, there's many different ways of modeling this problem, and with time, you'll find the ways you like the most. But one possibility is to consider the system your grocery list, which is currently in the state of empty, and you wish to bring it to the state of filled with the things you need. Now, let's think about what kinds of inputs are possible and how they affect the system. You can start by drawing a picture of a cat in your list. Is that good? That will take it away from the state of empty, but it won't bring it any closer to the state you want, so probably not a good input. You can try to remember from memory what you bought last time, or reflect on what you're in the mood for. If you write that down, you've got a list that's closer to the ideal state. But there's a very strong candidate. Just looking around your kitchen and your cupboards for what you're low on, or what you just run out of. This is great, and that's actually what I usually go for in this situation. Have we then solved the problem? Yeah. Remember, finding good enough inputs, not the perfect one. Bringing the system close to the ideal state, not necessarily exactly to it. But how good is good enough? How close is close enough? That will obviously depend on the problem. Worst case scenario, we just use the best input we can find, see how the system changes, and try it again, until we're satisfied or we give up. But most times, in fact, systems react relatively consistently to certain inputs, making it a lot easier to predict which ones are best. And that's how you can apply this idea to your problem, whatever it is. Find the properties of your system, and find the laws that govern these properties. That's what we do in physics. If I need to go outside and it's raining, I know rain is water, and I know how water reacts to a barrier. So if I don't want rain to reach me, I can just put a barrier between me and the rain. The system is the rain, the desired state is away from me, and my input is opening an umbrella. I know this is going to work before I even try it, because I know the properties of rain. So that's how you solve any problem in your life like a physicist. figure out the current state of things, and identify what you can do to bring those things closer to what you want them to be. Just a disclaimer here that in physics, usually the goal isn't to bring a system to a specific state, but rather to study the system itself. So eventually we know for every possible input which state the system is going to be in. And this can also be useful for daily life, because the more problems you solve in the same system, the more you understand about how it behaves, and the easier it becomes to solve all future problems relating to it. So, does that mean that from now on, all your problems are going to be easy to solve? No, but I hope to have shared a way of thinking that, if practiced, ends up actually improving your problem-solving skills and ultimately leading to a more successful and fulfilling life. Or some other ending to the video that implies some deeper, selfless reason to what I'm doing, apart from just enjoying the process. Anyway, if there's anything you'd like me to write about, let me know, and I'll see you in the next one.